This lecture is on a couple different ways to show that two triangles are congruent. So starting off with the idea that triangles have 6 parts, 3 sides, and 3 angles, and if you want to show that 2 of them are congruent, then you've got to match up all 6 parts, side, and angle, side, angle, side, angle, going in order basically around the triangle, side, angle, side, angle, side, angle. And then realizing that if you know 2 angles, you know the third because they add to 180, so that takes us down to SAS, so that's only 5 parts. We can reduce it further. And I'm going to talk about reducing it down to just 3 parts with side, 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 and also side, angle, side. Now with side, angle, side in particular, it's important that is the location of the angle, that the angle is between the 2 sides. That is, it is included. So this is what I mean by included. If you have 2 sides, if you know 2 sides, the included angle is angle B. Angle A is a non-included angle. Angle C is a non-included angle. Same thing works the other way. If you have 2 angles, this is going to go with what we'll talk about later. If you have 2 angles, this is an included side, XY. Side YZ is non-included, and side XZ is non-included. So included basically means it's between. Okay, so here's side, 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 first of all. We know these 3 sides, red, green, and black, and we can change them around, but we're going to have to go with those lengths. And the idea is there any way to make these things match up where we can get more than one triangle? And move it around. Is there a way to make them hit so I get more than one? And there isn't. You can only get one triangle. So even if you don't know anything about the angles at all, as long as you have all 3 sides corresponding, then you're good. And you know you have congruent triangles. Now, this also works for side, angle, side. So for side, angle, side, we're fixing the red and blue sides, and we're fixing this angle here. So you can move this pointer on anything you want, because you can make this as long as you want, and you can make it any angle you want. And is there any way to get these 2 things to match up somewhere down here? And so you're not allowed to move this because the length is fixed and the angle's fixed. So we can move this around, but either way we get the same triangle. So side, angle, side is also what's called a congruence relationship between these 2 triangles. So now we'll do some practice with this. Okay. So SSS and SAS postulates, we want to say, is it possible to use either of these to show that these 2 triangles are congruent? If not, you say not possible. If it is, you identify whether it's SSS or SAS, and you write a congruence statement, which means you have to get the letters to match up in some correct correspondence. Okay, so these sides are the same, these angles are the same. Now we know that BD is congruent to itself by reflexive. And so because of that, I can say that these 2 triangles are congruent by side, angle, side. See, I've got side, angle, side over here. So that's SAS, side, angle, side. Because here I've got a side, angle, side, and they match up. And so I could say triangle ABD is congruent to triangle CBD. So A's got to go with C, B goes with B, D goes with D. Now, if we switch the order of the letters here, that's fine, but we have to make sure that we switch the order of the letters over here to match up. Now for number 2, we have a side, side with side, side, and SS, that's not enough information. So 2 does not work. For 3, we've got a side, and an angle. Now SSA, that's no good. The angle has to be included. SAS is the one that works. Side, angle, side does not work, or excuse me, side, side angle does not work, so this one also is not possible. So you have to really watch where that angle is. It has to be included. Here we have side with side with side. So this one works by SSS, and we could say triangle TUS is congruent to triangle. Let's see, T is between the 1 and the 2. Get rid of these. T is between the 1 and the 2, and X is between the 1 and the 2. U is between the 1 and the 3, W is between the 1/3/, and S is between the 2 and the 3, V is between the 2 and the 3. So there's a congruence statement. For number 5, YA is the same as itself, and we know this will be a right angle too. So we have a side with an angle, side angle, but that's not enough information. So that one's not possible. For 6, we've got side, angle, side, and side, angle, side, so that works. So SAS, we could say triangle CDF is congruent to triangle, actually CDE, congruent to triangle FGH. So I'm not going to write out all of them at this point, but just do a little bit more. Here, this is congruent to itself by reflexive, so we've got side, angle, side, so that'll work. This is congruent to itself by reflexive, so side, side, side with side, side, side. And here, these angles are congruent by vertical, but this one does not work, no, because it's side, side, angle. This angle is not included. Okay. Draw a triangle and label it ABC, so A, B, and C. What angles between BC and AC? Okay, BC and AC, that would be angle C. What sides include angle B? Well, angle B is between side AB and side BC. What angles include AB? That would be angle A and angle B. You can see the letters kind of go together. What side is included between A and C? Well, that's simply side AC. Okay, now taking a look at some proofs. So, all right, we're given AB is congruent to DC. So you always want to draw a figure and label it, and it's already labeled for us. BAC is congruent to DCA, and we want to prove these two triangles are congruent. So first of all, this stuff is all true because it is in the given information. AC is congruent to CA, so I'll label that, and that's true because of reflexive. And then triangle ABC is congruent to triangle CDA, and that's by side, angle, side, so that's going to be SAS. So that would be our three-step proof. Okay, now for this one, we set up some statements, we set up some reasons. I write EF is congruent to FG, and DF is congruent to FH, and that's given. And we've already got a figure. If you don't have one, you got to draw it and label it. It's already labeled. Now we can say these angles are congruent, so I can say angle DFE is congruent to angle HFG, and that is by this vertical angles are congruent. And finally, we can say triangle DFE is congruent to triangle HFG, and that's going to be then side, angle, side, so that's SAS.